You're able to see? So we have 1.5 hours solid time. We'll utilize it. Okay. And maximum by tomorrow you have it. I hope you would have already got the information, right? No? Okay, you'll get it. So tomorrow 9:30, 12:30 we are handling it. You will be coming in? Yes. I know. It's fine. I'm not saying anything, but yeah. I mostly teach for you. So which problem are we doing? Did we start MTG problems? So I remember that CD square into something. CD square. Is it? So how many of you are confident with trigonometry also? Little confident. So there is a triangle ACB. Okay. So ACB, which is right angled at C. From C, you're dropping a perpendicular onto AB. Okay. Let me call this as D. Okay. So this. Okay. So we are supposed to prove that CD square is equal to BD into AD. The CD square is equal to BD into AD. How do I prove this? So how do we prove? So what are the two triangles that we can consider? So I can think of triangle ADC and triangle BDC. Is that right? So if this angle, for example, let's say 2 is x, then how much will this angle be? 90 minus x. Because angle phi is given as 90. Is that right? So this is 90. Here also it is 90. So on the other side also it is 90. If angle 1 is y, then what is angle 3? Is it right? You didn't understand it. Simple, no? So if this is y, this whole angle is 90, then how much will this be? If I call this as, for example, alpha, y plus 90 plus alpha is how much? 180. So what is the value of alpha? 90 minus y. So whenever you have a right angle triangle, the third angle will be 90 minus whatever is the other angle. So here it is y, here it is going to be 90 minus y. But tell me, what is the relation between x and y? Can I say x is equal to 90 minus y? Can I say x is equal to 90 minus y? How? Because if you take the right angle triangle ADC, if this is x and this is y, x plus y is 90. So x will be 90 minus y. Is it clear? So what I'm actually trying to do is I'm trying to convert everything in terms of x only. Okay, I'll tell you why I'm doing this. I'll solve the problem in two ways and show it to you. Whichever is easy, you can pick it up. Okay. So x is equal. Is it clear till this step? In a similar way, how much is this angle? 90 minus y. Then how much is this angle? 90 minus x. So what is 90 minus? I'll do one thing. I'll make it simple. What is 90 minus x? 90 minus x is y. 90 minus y is x. So if you observe the three angles of triangle ADC, they are x, y, and 90. If you observe the three angles of C, D, B, and B, they are again x, y, and 90. So what can you say these two triangles are? According to the AA criteria, you can say that they are similar. Right. So which two triangles are going to be similar? Angle CDA is similar to triangle BDC. Is that right or wrong? Is there anyone having any confusion? Is it clear? Because angle C is x. In this triangle, angle B is x. So angle C and angle B, I ensured they are written first. Then the 90-degree one is D. Other angle you already know. So CD divided by, what do we need? AD is equal to BD divided by CD. Is that right? So what can we prove from this? CD square is equal to AD into BD. Is that what they asked? Am I right? Did you understand what I did? So I'm using only one logic. I'm not even overthinking. If you see, I'm using only one logic for similar triangles. What is it? I'm not concerned about the sides. But what should exactly be the same for two similar triangles? All the angles are supposed to be equal. So I tried to find what the angles and I proved that they both are similar. They cannot definitely be congruent because they didn't give it as an isosceles or equilateral triangle. So it's some scalene triangle only. So I hope it is clear. So make a note of this. I'll teach you an alternate way also. Is there anyone who's not confident with the basics of trigonometry also? Like you don't know what is sine, cos, tan. You know all those things that you're confident. Should I proceed? So if you observe the same problem, C, this is A, B, drop the perpendicular, this is D. Is that right? So if I take this angle to be theta, then how much will this angle be? Observe. if I take this angle to be theta, I already did it in the previous case. How much is this angle? I already told you. 90 minus theta. Is that right? So if this is 90 minus theta, how much will this angle be? Theta, right? So I'm taking two right angled triangles. What are the two right angle triangles? CDA and CDD. Clear? Okay. In these two triangles, which side is common? CD is common. So is there any trigonometric function, okay, trigonometric ratio that you can think of which involves vertical and the horizontal? So what are the trigonometric? So tan is the trigonometric ratio which includes only vertical and horizontal. Vertical means the one which is standing and the one which is sleeping, right? Others will include hypotenuse, right? So if I take this to be theta, what is tan theta from this triangle? AD. What is tan theta from this triangle? DD by, sure, because with respect to theta, BD is the opposite and CD is the adjacent. Is there any doubt in this step? So left hand sides are tan theta, right hand side should be CD by AD is equal to BD by CD, cross multiply. What is the answer? Isn't it the same? So wherever you get stuck with respect to triangles, you can always think of making it a right angle triangle and update it. You cannot take B as theta, no, because it is not theta, it is 90 minus theta. According to geometry, it is 90 minus theta only. Okay. So I'll just explain the other concepts, then we can do the level 1 problems. Shall we proceed? Now see. Areas of similar triangles. So what does the statement tell you? It's fine, it's better, you know. Not a big deal. So what does it state? Read the statement. So if it is deleted, better you make a note of it. So ratio of areas of whom two similar triangles are not are is equal to the ratio of whom? Ratio of squares of the corresponding ratio of the squares of corresponding sides. So what is the meaning of a triangle? ABC is similar to triangle PQR, which implies area of triangle, area of ABC divided by area of PQR is how much? AB square by PQ square is equal to BC square divided by QR square is equal to AC square divided by PR square. Okay. So this is the meaning. Shall I proceed? Yeah. So what is theorem 7? So what is it stating? It's in page 160. Read it. If a perpendicular drawn from the vertex of vertex of right angled triangle, then what will happen? So when you drop a perpendicular from the right angle to the opposite side, means what would be the opposite side of the right angle basically? What is hypotenuse basically? Hypotenuse is the side which is opposite to 90 degrees. So if a perpendicular drawn from the vertex of right angle triangle to whom? Obviously that side is called as hypotenuse. Then what is going to happen? Okay, you do this. Then what is the outcome expected out of it? Then triangles of both sides of the perpendicular are similar to the whole triangle and each other. Then what did they say? Then the triangles on both sides of whom? Of the both sides of the perpendicular are similar to the bigger triangle and each other. So if you see, this is what we did in the previous problem, right? So if you look at the triangle, it was given like this: A, C. Okay, I'll take this as A, B, C. From here, the perpendicular is dropped. So which two triangles are similar? For that, observe the angle. Here, the angle is theta. Here, it will be theta, right? So which two triangles are similar? Triangle ADB is similar to triangle CDA is similar to triangle so which angle? It's similar to triangle CAB. You didn't understand the theorem. See. So yeah, that's right. So if you take a right angle triangle, from the right angle's vertex, if you drop a perpendicular onto the opposite side. So this is 90 degrees. From this vertex, if you drop a perpendicular onto the hypotenuse, then three triangles are similar to each other. What are they? So what is the statement? The triangles on both sides of the perpendicular means this triangle and this triangle are similar. And they are similar to whom? They are similar to the bigger triangle itself. That is the meaning. Okay. So now try to connect the dots. Triangle ADB. Why did I write ADB? If I take ADB, this angle is 90 minus theta. Right. So since I wrote A first, T, that is 90 degrees in the middle, and theta angle at the last. Okay. Then what should be the corresponding points on the other side? This is 90 minus theta. So corresponding point of A here is 90 minus C. D is D only. Then A. Is similar to triangle. For the bigger triangle, where is the right angle? Right angle is at point A. Right. So what are there on either of the sides? Yes. So C is 90 minus theta, B is theta. So that is why I wrote it the exact order. Is that clear? Shall we proceed? Okay. So based on this, let's do the example number 9. Prove that the ratio of areas of two similar triangles is equal to the ratio of the squares of their corresponding altitudes. Try it out. Whatever you want to use, you can. If you want to go with theorems, go. If you want to use trigonometry, use trigonometry. Read the statement. So how will you prove? Don't look at the solution. You use your logic. I already gave all the hints. See, basically, if you want to find the area, what are all the required data? Half into base into height. You do something with that. Or what did they ask? If you have two similar triangles, for example, which two triangles are similar here according to the way we constructed? Maybe if you want to say triangle ABC is similar to triangle DEF. Okay, these two triangles, if you want to say that they are similar, then what should happen? If this is alpha, this should be alpha. This is beta, this should be beta. And if this is gamma, this should also be gamma. Okay. Now you have an altitude. What are they expecting us to prove? You need to prove that if you find the area, they are equal to the ratio of squares of their corresponding altitudes. So how will you bring the altitude into area? Think about it. Or you want to think in terms of the theorem that I told you in theorem number 6. Look at the theorem 6. No, what does theorem 6 tell you? I know you wouldn't learn it, but at least now try to apply it. No? What does it state? If there are two similar triangles and the ratio of their areas is equal to the square of their corresponding sides. First, try to find out which two triangles are similar. For that, you can take the help of theorem number 7. So wherever you drop a perpendicular, I'm sorry, theorem number 7 can't be used because it is applicable only for right angle triangle. You can't use it. But by you dropping a perpendicular, aren't you constructing two right angle triangles? See what is the relation between those two right angle triangles. Any suggestions? So what is given? Any suggestions? So this is given already, right? ABC is similar to triangle DEF because I told two similar triangles are given to you. Your job is to drop an altitude. If you drop an altitude, then you prove that the area of the ratio of area of these two triangles is the square of their altitudes. So how to proceed? So since triangle ABC is similar to triangle DEF, what will be the relation between their sides in terms of similarity according to basic proportionality theorem? AB divided by DE is equal to AC by DF is equal to BC by EF. So let this be equation number 1. We don't know where it will be useful for us. But whenever they say triangles are similar, this is an indirect information that is given to us. It is a hint. Now, what are we supposed to prove? If you are able to prove, then what does theorem number 6 tell you? Theorem number 6. Is there a way you can prove that the triangles here and here are similar? Like when you break, after you break it, after you drop the altitude, is there a way you can prove that they are similar? How? According to what criteria? So one angle, if I take, for example, if I take the triangle AMB and if I take the triangle DNE, you already know that these two triangles are similar. So if they are similar, angle B and angle E are the same. By you dropping the perpendicular, what did you do to the angles at the input of the perpendicular? So two angles are same. Obviously, third will be same. So they both are similar according to AA criteria, right? So can I write AM divided by AB is equal to DN divided by DE? Hypotenuse, right? Can I write it? So what is that we need to prove? We need to find the value of AM square and DN square. For that, observe, I'll rearrange the equation and write it as AM divided by DN is equal to AB divided by DE. Am I clear with this? So if I square on both the sides, what will I get? I'll write it here. If I square on both the sides, I'll get AM square divided by DN square is equal to AB square divided by DE square. So AB square by DE square is already the ratio of areas. So what can I replace AB square by DE square with? AM square by DN square. Aren't they the square of the altitudes? That's it. We are done. Is that clear? So if you observe the steps that we followed, what did we do first? Whether it is useful or not, when they say two triangles are similar, first write down the ratios. Second, since they asked us to find something in terms of areas. So we know that the ratio of areas of two similar triangles are equal to the squares of the sides. Write that statement also. Then whichever triangle you need to take the altitude from, consider those triangles and prove them to be similar, and then take the corresponding sides to be in the same ratio. Then replace the main sides with altitudes. That's what I did. Okay. Please make a note of this. Shall I proceed? So do the 10th one. Read it. You copy it. That's the answer. But just now we proved. Do we need to solve that problem? Do we need to solve that problem? Because just now we proved something, right? We proved it, no? So answer will be 4:5. Why? Because according to the previous problem, area of triangle ABC by area of triangle DEF is equal to AL square divided by DM square. The ratio of the squares of the altitudes. So 16 divided by 25 will be equal to AL divided by DM square, which implies AL by DM is equal to 4:5. That's it. Right. So do the 11th one. The areas of two similar triangles are 121 square and 64 centimeter square respectively. If the median of the first triangle is 12.1 centimeter, find the corresponding median of the other. So, if you go back to page 159, go to page 159. There is a box, right? Competition window. In that, read. First point, the areas of two similar triangles are in the ratio of the squares of their corresponding altitudes. Similarly, the ratio of two similar triangles are in the ratio of the squares of their corresponding medians. Third point, the areas of two similar triangles are in the ratio of the squares of their corresponding angular bisector segments. Bisector segments with that portion that is obtained. You have an angular bisector, right? To draw the portions, right? Similarly, if the areas of two similar triangles are equal, then the triangles are said to be obviously congruent. Okay. So are you able to understand? So using the second point that is given, can you solve the 11th one? So if I take triangle ABC is similar to triangle DEF, area of triangle ABC is how much? 121 divided by area of triangle DEF is how much? 64. This should be equal to sum of the squares of their medians. So AP square divided by DQ square. What is AP square? 12.1 square divided by DQ square. So 121 divided by 64 is equal to 12.1 divided by DQ, the whole square, which implies 11 divided by 8 is equal to 12.1 divided by DQ, which implies DQ is equal to 12.1 into 8 divided by 11. Calculated that. Is it 8.8? This is 1.1. No? 1.1 into 8 is 8.8. Understood? Right. So next is an interesting one. Try to solve it. How to solve? Prove that the area of an equilateral triangle described on the side of a right-angled isosceles triangle. So first you have right-angled isosceles triangle. And for this right-angled isosceles triangle, what is constructed? Read the question. Read it. No. So two are constructed or three? If you see the statement, they are constructed on a side of a right-angled isosceles triangle. Why only two? Why not three? Three sides are there, no? Because two sides will be of the same value, right? So you need not construct the third one. So how much will this be? Root 2x, right? So if I construct an equilateral triangle here, right, then how much will this side be? Root 2x and root 2x. If I construct an equilateral triangle here, this will be x and this will be x, right? Prove that the area of equilateral triangle described on a side of right-angled isosceles triangle is equal to half of the area of the equilateral triangle constructed on its hypotenuse. So what is the area of an equilateral triangle? Root 3 by 4. So this is 1 and this is 2. So this is the area of the first triangle. What is the area of the other triangle? Root 3 by 4 into 2x square, because root 2 into x square, 2. So 2 divided by 1 will be how much? Root 3 by 4 into 2x square divided by root 3 by 4 x square. Cancel it. X square gone. 2 is to 1. Right. This is the area of the triangle constructed on the hypotenuse to the area constructed on the side. But what did they ask? The ratio of side by hypotenuse is what is? Half. Did we prove it? Did you understand or no? Yes. So how many more chapters are pending for your? That's it. 3. Not there. No. Shall I proceed? Okay. Shall I proceed? Yeah. So you already know this, right? So what does it state? So if I have ABC, AC square will be equal to AB square plus BC square. And this is applicable only for obviously a right angle triangle. So what are the converse of this? If the sum of the squares of two sides is equal to the square of the third side, then there is a right angle. Okay, where will the right angle be? Where will the right angle be? Opposite to the side, opposite to the resultant side square. Resultant means it is the output that you are getting. Okay. So having this in mind, let's try out problem number 13. So in triangle ABC, angle B is 90 degree and D is the midpoint of BC. Prove that AC square is equal to AD square plus 3 times CD square. How to prove? See, whenever you have sum of squares, the first thing you need to do is apply Pythagoras theorem. So for you to apply it, first you need right angle triangles. How many right angle triangles are you able to see? You're able to see two? Yes. What are the two right angle triangles? If I take triangle ABD, that implies, so if you write it in the correct order, right, you need not look at the triangle again. If you make sure that right angle is at the center, then by looking at the triangle, you can write it that AD square is equal to AB square plus BD square. Is that clear? Similarly, if you consider the triangle ADC, then what can you write? But what is BD? Not ADC, I'm sorry, ABC. Then what else can we do? What are we asked to prove? AC square is equal to. So how to prove that? So if you look at the value that is to be proven and look at the two mathematical expressions that we have, which is the unwanted square that we have in it. So look at what is supposed to be proved. AB square is unwanted. So what I can do is I can subtract both those equations. So when if I take this as 1 and this as, but AB will remove it. Why I'm saying AB is not needed is because if you want this 3 times CD square, it is going to be on the horizontal and this AD square is there. So you're not needing the vertical. So eliminate that vertical. To do that, what can I do to those two equations? Subtract both. When I do 2 minus 1, I'll get AC square minus AD square is equal to BC square minus BD square. Can I write it like this? So AC square is equal to AD square will go to the other side, AD square plus BC square minus, what is BD? Is it not BC minus CD? So this will be equal to AD square plus BC square minus BC square minus CD square plus 2 times BC into CD. So what will get cancelled? These two are gone. So this 2 times BC into CD, if you are able to prove that it is 2 CD square, your job is done. How is BC related to CD? Can I say BC is 2 times CD? So this will be equal to AD square minus CD square plus 2 into 2 times CD into CD. So this is giving you 4 times CD square minus 1 times CD square is plus 3 times CD square. Clear? So this will give you AD square plus 3 times CD square. So the thought process is wherever some of the squares are there, go with Pythagoras theorem. But you need to look at how to solve those two equations. In this question, did you understand that we are supposed to subtract them? That is more important. Had you added both the equations, you would have had 2AB square in your hand, which you would have not known what to do with. Right? I got headache. Customer came with that. That's good. You didn't learn something. Fully delivered. We call it as base. Now we have to first. That is used for what we give to frequencies. Only up here calculator. You have this sound system. Everybody has. Okay, go to watch movies. I have a base frequency is going to travel for a longer distance. And they resonate actually. That is the building process going on there also. I can sense it. People irritating for it. That is why when a lorry or something is crossing, right? Have you ever seen this? When you stand on the road and a lorry is crossing, you feel some vibration near the roads. The roads are weak. Have you ever observed it? That is called as resonance. It's actually resonating. The frequency is actually matching. And both sides you learn something. Actually, it is in this system. Keeping one system. Okay, shall we proceed? So try the 14th one. PL and CM are sure.
You got the information regarding tomorrow's title. What's the time? Saturday.
Okay, try the 14th one. PL and CM are medians of triangle ABC. Are medians of triangle ABC. Fourteenth. So what do you mean by median? Median is a line that divides the opposite side in the ratio 1:1. BL and CM are the medians of triangle ABC. And remember, this triangle is right angled at point A. Then prove that 4 times BL square plus CM square is equal to 5 times BC square. Have you ever done these kind of problems? This is also deleted. Area, Pythagoras. That is also deleted. Okay, try this out. So you're able to observe the sum of these two squares and you have a right angle triangle. What are you supposed to look for? Try to break them into multiple right angle triangles and then apply Pythagoras theorem. So how many right angle triangles do you have? I'm able to see 3. What are 3? BAC is the bigger triangle. BAL is the smaller part. Okay. So these are all the right angle triangles. Since you have written it in the correct order, then what can you say? BC square is equal to, okay, or BA square plus AC square. Then what about this? BL square is equal to BA square plus AL square. CM square is equal to CA square plus AM square. Okay. So we need to prove that 4 times BL square. So BL is here. So I need to get 4 value here, 4 here, plus 4 times CM square is equal to 5 times BC square. How to solve? No need. No. I'm looking, see, I'm just trying to connect the logic and try to solve. So if I look at the second and the third expression, I'll get the left-hand side of what is supposed to be proved. BL square plus CM square. Will I get it? But what is missing on the left-hand side? 4 is missing. So from here, can I say 4 times second equation plus 4 times third equation will give you 4 times BL square plus DM square. This is equal to, can I write it as 4 times BA square plus AL square plus AC square plus AM square? Can I do this? Observe. Can I do that? So I multiplied the second equation with 4, third equation with 4 and added them. Can I do that? So when I do this, I got the left hand side 4 times BL square plus BM square is equal to 4 into what is BA square plus AC square? So 4 times BC square plus I have AL square plus AM square. So do something to this and solve it. So the only hint you have in the problem is You know that AL and AC are related. How? AL is equal to AL and AC. In what ratio are they? Their ratio 1:2. Because it's a median. What does a median do? They have given it in the problem now. So median means AL is equal to LC. So AL will be equal to half of AC. Using that, try to solve the problem. Actually, it is only 2 more steps. Half of AC square plus AB square will become BC square. You're done. Got it? So try to solve it. So is it clear to everyone? Most importantly, are you able to understand how to think? Are you? So try to do it on your own. Since I explained the logic, try to do it on your own. Take your time. You understood? See, I'm writing this. See, everybody has done the same mistake. This is CM square. Okay. So I'm taking only the right hand side. 4 into what do we have? BC square plus AL square plus AM square. So 4 into, I'm not disturbing BC square because we want the final answer in terms of BC only. Plus AL is what? half of AC. So when I square on both the sides, I get 1 by 4 of AC square. So everybody has missed this 4. You wrote it as 2, you will not get the answer. So it is 1 by 4 into AC square plus, because AM is half of AB. So 4 into BC square plus 1/4 of BC square. Why 1/4 of BC square? Because AC square plus AB square will be BC square. Right? 5 BC square divided by 4. 4 and 4 will get cancelled. You will get 5 BC square. Did you understand? See, for this chapter, I suggest you all to practice the solved examples part also. You try to solve the problem in 2 or 3 different methods and then see it. Okay, level 1 problems, I'll start. Shall I do that? You have NCERT solutions also here. Did you check it? So page 186, level 1 problems. So first one, tell me. I think all these problems will be simple only. So in the given triangle, DE is parallel to BC, right? DE is parallel to BC means what comes to your mind? What theorem comes to your mind? Basic proportionality theorem. So that AD is 2.4. AE is how much? 3.2. EC is how much? Then can you find AB? So what can you do in the first place? AD divided by DB, you can write it as AE divided by BC. Can you do that? So what is AD? 2.4. DB is, we don't know. AE is 3.2 divided by EC is 4.8. So 3.2 and 4.8. So this is 1.6 and this is 2.4. But it goes in 8, right? So 0.4 divided by 0.6 or point. So dB is equal to, okay, 2.4 into 3 divided by 2, 1.2, it is 3.6, no? So it is 3.6, wait, 3.6 is not the answer. 3.6 plus 2.4 will be the answer because they didn't ask what is DB, they asked AB. AB is equal to AD plus DB. So 2.4 plus 3.6 will give you, is there an option? They're confused. That's the first option. I told you they will do that. Be careful, okay? 6 centimeter. So I think these problems will be simple only. Can we have some timer and then solve them? Can we give 1 minute for each problem? Yeah. So do it. DE is parallel to BC so that AD is 7x minus 4. AE is 5x minus 2. EP is 3x plus 4. EC is 3x. The value of x is. Application of which chapter? So what is the answer? Whole of 1 by 3, right? So option C is right. So shall we do the third one? So how many of you couldn't solve this? In practice quadratic equations. Yeah, yeah. You completed coding. Don't wait for. So which two triangles are similar? Which two triangles are similar? Is there any similar triangle in the first? Are there similar triangles in the first place? No. solve? Logic. See, I told you, no, if at all you have no hint in your hand. Okay, BC is 7.5. Okay, this is 7.5. Then this is how much? 2.5. So BD and DC and what ratio are they? 2:1? This Saturday will not have any class. Today. When did she? On Saturday. I'll discuss it. But, yeah. No, but let me discuss and come back. But I'll update you on that. I'll update you. I'll update. So how to solve this? Let's start with this problem. I'll start trigonometry mostly. See, there is a property called internal bisector property based on. So that's 2:1. This one, this, sir. So I told you, think in terms of angles. If this is beta, this will be 180 minus beta. Then how much will this be? Then how much will the third angle on the right side be, and how much will the angle here be? This will be 180 minus of alpha plus beta. Then how much will this angle be? You keep doing, no, I'll prove it. You keep doing the next one. Do the fourth one. So what is the answer for the fourth one? See, actually, these two triangles will not be similar. Like, we can't prove they are similar because the angles are not equal. See. Okay. Which one? ECM? That's what they're given. No? And the diagonals AC and BD intersect at point O. AO is equal to 3x minus 1. BO is 2x plus 1. And what about OC? 5x minus 3. Which one are you saying? Okay. For fourth one, what are you trying to prove? So which are you trying? You're trying to do the which two triangles are similar that you're trying to find out. Okay, then write the corresponding sides. They are in the same ratio. Which two triangles are similar according to you? CA. Okay. So which criteria? Okay. So what is the answer? So what is the answer? See, for you to solve the fifth one, I have to tell you this property. So there is a property called internal bisector property. You know what it is, right? So if there is an internal bisector, then what will you say? The ratio of the sides AB by AC will be equal to BD by DC. You know this, right? So this is called as internal bisector property. So when you have an internal angular bisector, then on either side of the angular bisector, you have sides, right? So those sides are AB and AC. The ratio of AB and AC will be equal to the ratio of the size into which it is dividing the opposite side into. Okay, that is BD divided by DC. Okay, so using the same logic, if you look at the fifth problem, right, what did they say? AB by AC is equal to BD by DC. Again, they have used the internal bisector property. So when you look at the triangle itself, what you can say is angle B is 70, angle C is 50, the angle BAD will be how much? So how much is this total angle? 60, no? So total angle is 60. Since it is an internal bisector, it will be 30. That's the answer. How did I say it's an internal bisector? Because they've given the ratio already. So we'll do one last problem. In triangle ABC, AD is the bisector of angle A, then area of triangle ABD divided by area of triangle ABC. Sorry, ACD. Go to the competition window on page 159. Page 159 at the bottom. Oh, that is only for similar triangles. They didn't give you the similar triangle. I'm sorry. So AD is the bisector of angle A, then area of triangle ABD divided by area of triangle ACD is how much? AB square by AC square. But they should be similar, no? You cannot. It's an angular bisector part, you cannot prove there. Actually, we can continue tomorrow at class 5:30. So tomorrow we'll do a few more problems and then we'll start trigonometry. First is? Yeah.